Hello everyone, in this video I want to share about what I had learned in my physics class, specifically about the evidence that magnetic flux can only be dipoles while electric flux can be both monopoles and dipoles. And I think that's an interesting topic because I've even read an article online saying that as of now, magnets are dipoles and maybe in the future they can be proven to be monopoles as well, and I'm not sure why. So I did some studying about why magnets are dipoles, always dipoles, and I've come across this formula for Gauss law in magnetic flux and Gauss law in electric flux, and I thought that they are the reason behind why magnets are always dipoles. But turns out no, they're more like the evidence, they're more like the proof that magnets are always dipoles. So as you can see, there are two images of one is a magnetic field, the other is an electric field. And can you guess what this is? Obviously this is a Gaussian surface, an object that is blocking the magnetic field, where the magnetic field will pierce the object to form magnetic flux. So yeah, basically the proof or the evidence that magnets are always dipoles and electric fields are always dipoles and monopoles can be both of them is that it can be found in their own flux for magnetic flux and electric flux. Basically, at one specific point within the magnetic field area, magnetic flux will always be non-zero. However, in the whole field, the total will always be zero. If a magnet is monopole, then the net magnetic flux could also be non-zero. However, net magnetic flux is always zero all the time. I mean, considering that they go out and go into again and go back to where they're from, and that means it's always zero. And of course, unlike magnetic fields, electric fields can be both dipoles and monopoles. So essentially, yeah, same like why magnets can only be dipoles, there is no apparent reason why this happens. However, it can be proven in the form of the electric flux. If a Gaussian surface is blocking an electric field, the electric field piercing the Gaussian surface is electric flux. And the formula relevant will be the Gauss law for electricity, which is electric flux equals the integral of electric field times the derivative of area, which is also equal to the total of enclosed charge divided by permittivity of free space. And yeah, this basically proves that this can both be zero and non-zero. The time where it will be zero is when the positive charge and the negative charge balance each other. So basically, if there are, for example, two enclosed charge with two enclosed, if there are two enclosed protons with two enclosed electrons, that means they will result in 0. 0 divided by 8,85 times 10 to the power of negative 19, which is basically just 0. And that is what happens when it is a dipole. I'm sorry, it's not 19, it's 12. And when it is non-zero is when it is like two protons divided by one electrons. That means the permittivity of free space there, and that means it will be one enclosed charge divided by 8,85 times 10 to the power of 12, which is 1.6 times 10 to the power of negative 19 divided by 8.85 times 10 to the power of 12, which is not 0, which is also greater than 0, which means that it will become a positive monopole. The same applies if there are more electrons than protons. For example, like maybe it has 0 protons and maybe 1 electron, or maybe like 2 divided by permittivity of free space is like mean 2 times 1.6 to the power of 19, which is lower than 0, which means it's also a monopole, a negatively charged monopole electric field. So yeah, this is basically the evidence that magnetic flux is always 0 all the time, while electric flux can be both 0 and non-zero. Maybe while we're at it, we could also note about what magnetic field is. It is basically permeability of free space multiplied by current divided by the clearing, what is it again? The circumference of the loop of the magnetic field, which is 2πr. And this is basically just permeability of free space, and it is like 4 pi times 10 to the power of negative 7 in Teslas, or 4p times 10 to the power of negative 7 in kilogram meter per ampere second. Both are squared, and I is basically just current. It's in ampere, and current can be found from dividing voltage by resistance, basically voltage divided by ohms. And for the derivative of area, it's basically just like the small patch of area where the magnetic field is piercing through the Gaussian surface. It can be anything. It can be like a square, it can be like a circle, which is, yes, it can be like this, and it is all for area. And also as for electric field, it's basically just Coulomb's constant multiplied by the charge divided by the area from which you want to measure the electric field from. For example, like if the charge is here and you want to measure it maybe like here, then the area from here to here is like that. And Coulomb's constant is basically 1 divided by 4 times pi times permittivity of free space and times charge divided by area. And this is basically the formula for electric field. So as a side note, even when it has like 3 protons and 1 electrons, or like 5 electrons and 1 protons, it will still be considered as a monopole, not a tripole or a quadrupole, etc., etc. Because it counts the characteristic of the electric field more, like it's positively charged or negatively charged. That's all I have to say for this video. I thank you for listening to my video. I plan to make more like this because it helps me learn, and I hope it can help those of you who are interested in learning this subject. Thank you very much.